All right, so this will be a three-part series, three-part video where it'll be mainly focusing on the Cartesian plane. This will be a three-part video where it mainly focuses on the Cartesian plane, which is this here or this here, x and y, and your geometries. So that's your squares, your triangles, etc. Right? Okay. So, first question. Equation of a straight line is drawn below. Alright, first, what is a straight line? A straight line is y is equal to mx plus c, right? Where y is your value on your y-axis, x is your value on your x-axis, right? M is the gradient, right? And how do you work out the gradient? You say delta y over delta x, right? Remember, y over x, not x over y. It'll be y over x, which is equal to y2 minus y1 divided by x2 minus x1. All right. Gradient also determines the slope of the graph, right? Be it like this, be it like that, be it like this, or even that, right? These all have different gradients, and they all worked out using this, right? So that's the gradient, right? Which is m. C is what determines the vertical shift of the graph, right? Or I don't know if you guys know about the vertical shift, but this is also just the y-intercept, right? We can first look at the y-intercept, right? Y-intercept, which is c, right? Y-intercept on this graph, this is the y axis, and the value intercepting this axis is 2, right? Positive 2, right? So this one here is incorrect because that's a negative 2. And so is this one, because these are negative 2's, right? Remember, the C is equal to the y-intercept, right? It is not equal to the x-intercept. Remember, this here is the y-intercept and this here is the x-intercept. Y-intercept because it's on the y-axis, x-intercept because it's on the x-axis. Alright, so we're just left with these two equations, right? Now, how do we work out what this what the gradient is? Well, let's just take two arbitrary points. Let's take this point, right, which is, remember, x is first, it's in this form, right? So x is dot 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 2, and y is 4, right? And then let's take why not this point? This point is the easiest, right? This is going to be x is is minus 2, and the y value is 0. So let's see. M is equal to delta y over delta x, which is equal to y2 minus y1, x2 minus x1, which is equal to y2. Let's make this our second value, and this here our first value, right? So minus 2 minus 2. this here, is it correct or incorrect? Incorrect, exactly. Why? Because those are the x values. So let's do this. This is our x, this is our y, this is our x, this is our y, right? y2, x2, x1, xy. So let's then just substitute. So y2 is 0 minus 4, and then x2 is minus 2 minus 2, which is equal to minus 4 over minus 4, which is equal to 1, right? So therefore, if we use y equals mx plus c, our m will be equals to 1, right? And our c will be equal to, what's the y-intercept? 2. So it's equal to this, which is equal to c. Which is equal to b. And there you go. This question, this is more of a geometry question. Also, I've noticed that question 1.3 in 2018 and 2019 was a straight line graph, and question 10 was both a geometry question. All right. So in the triangle PQR, so they gave us this triangle PQR. All right. QR is extended to S. So this normally means, when they say extended, right, this normally means that there's an extraordinary angle involved, right? And since they gave us a triangle, we have to use one of the triangle, like something related to a triangle. All right, so they want the size of angle Q, which is this one. How do we do this? Well, let's first work with what they gave us. So they gave us a triangle PQR, right? So, and they want this one. Let's call this, angle Q. So, one of the things of a triangle is that all the angles add up to 180, right? So let's do that. So that's angle Q plus 2x plus 4x is equal to 180 degrees, right? So angle Q, let's just simplify this, plus 6x is equal to 180 degrees. All right. But then they also gave us this part. Like we can't go any further than this because we don't know what the value of x is or the value of angle Q is, right? But they gave us another thing. They gave us this here, which is this here, right? Extended normally means exterior angle. And what do we know about the exterior angle of a triangle? The exterior angle of a triangle is this one. Is equal to the interior opposite angles, equal to the sum of them, right? So in this case, it's the interior opposite angles. So 7x is equal to 4x plus angle Q, right? 7x equals 4x. Let's bring it to that side, so that will be 7x minus 4x is equal to angle Q. What's 7 minus 4? Right? So we know that angle Q is 3x, right? But don't we have angle Q over here? Right? So let's sub it into there. So we have 3x plus 6x is equal to 180 degrees. Now can't we work out x here? We can, right? So that's 9x equals 180 degrees, right? And then x is equal to 180 degrees divided by 9, right? Therefore, x will be equal to, what is 180 divided by 9? It's 20. So x is equal to 20 degrees, right? So is this answer? No, it's not, because they're not asking for x, they're asking for angle Q. And we saw that angle Q is 3x, right? And we have the value of x. So let's substitute x into it. So 3 times 20 is angle Q, right? Therefore, angle Q is equal to, what's 3 times 20? 60 degrees. So D will be your correct answer. All right. Question 5.1. All right, so they are giving us that the diagram below, AC is parallel to HF. AC, right, is parallel to HF. Now, as soon as they say parallel, right, we have to think of the fun. Oh, all the fun we're gonna have, right? Where this and this, this and this, this and this, right? Where F represents the curve, right? The curve or the corresponding angles, where this and this are equal, right? This one here is the coint angles or point, right? Where the coint angles are supplementary, meaning they add up to 180. And then this one here, which is you can say out or outs, because the n is just also a z just turned around, right? So you can say outs. So curve coint outs. Yeah, that's for the parallel. Okay. They also gave us that BF is parallel to CD. Where's BF? BF is parallel to CD. So then let's also FUN. This one, this one, this one, this one, this one, this one. These two angles are the same. These angles are supplementary, and these two angles are the same. All right. So just from that, we got a lot of information, right? Then they tell us that angle CBF, which is angle CBF, B is in the middle, so that means that is the value. Oh, that's the one that's going to get the value. It's 85 degrees, right? And they say angle GFH is 50 degrees, right? Find with reasons the size of X and Y. All right. So let's find X first. So X is over here, right? Let's see if we can get anything with the since they gave us this first, right? We'll probably have to use this one first. All right, so let's see. Can we do anything with the F, right? That's curve. So here's this line. There's this line. Can we make a F? No, we can't make a F, but we can make a U. All right, interesting. Okay, so we can make a U. So that could mean that we could use that this angle here, let's call it A. Oh, let's call it B, right? B plus x is equal to 180 degrees, right? And we can get b by saying 180 minus 85 degrees. Oh wait, this will be coint because b or AC is parallel with HF, right? And b is equal to this because y? Straight line, right? And then we could sub that in and do everything like that. But, right, before we do it that way, why not let's look if we can make a z, right? This one, and this one. Let's see. If I make a z like this, right? But look at this, right? Z, the z is that this and this and are equal, right? If we make it like this, into a more of a this and this are equal, right? Let's just extend this a bit more. Be like that, be like this, be like that. This is what we have here, right? This and this. Remember, these ones have to be parallel. This one doesn't, right? So x will be equal to x is equal to 85 degrees. Why? Because alternating alternative angles are equal, where AC is parallel to HF. Remember, you have to mention the which sides you were referencing as parallel. All right. So that was that question. That's how we got x. So let's just mark this in. Yeah, so this is 85 degrees. All right. So now we're working with y, and we're using this one, right? Where BF and C are parallel, right? Let's see, can we make a F? We can. We can make an F over here. Oopsie. We can make a F over here where this angle and this angle are equal, right? We don't have this angle. We can work it out, but there's a better way we could do this, right? We can make a F here, but this doesn't really help us solve y. It could where we do this and this are equal, where we add this up to make this, and then we do coint angles, right? But this is only for 2 marks, so let's find a better way. Instead of making an F, let's see, we can make a Z. In order to make a Z, we need a thing going this way, going that way, and then going the other way, right? Like this, right? So if we do this, this is valid. This is valid. This is not valid because we don't have one going this way, right? If there was another line going this way, then this would be valid because we could go this and this. Similarly to this one, where we don't have anything going like that, right? We have this one, but it stops right there. It doesn't continue going on like this. If we had it like that, then we could make a Z, but we can't. So that only leaves with a U. Let's see, a U, this one and this one has to be parallel, right? Which is the case here. This and this are parallel. So let's make a U. Let's see, that and that, right? Which means 85 plus y is equal to 180 degrees. Why? Because of coint or coint, right? Coint angles are supplementary. And then don't forget, we have to mention which lines we will be using. to prove it, right? Basically the parallel ones, where BF cut is parallel to CD, right? And then Y is equal to 180 minus 85 degrees, which is equal to 95, I think. Let's see. 180 minus 95. Yeah. Oh, sorry. 180 minus 85 is equal to 95 degrees. So we got X to be 85 degrees and Y to be 95 degrees. Question 5.2. So in the diagram below, triangle MNO, which is this one here, the big one, right? With MN parallel with QP, right? Where this angle is 55 degrees, angle QPO is 3 3x plus 40, and where this angle is this angle being MON 2x minus 5. They want us to calculate x, right? So a nice and easy way to calculate x is since this is a smaller triangle within this bigger triangle, right? We can work out x by saying 3x plus 40 degrees plus 2x minus 5 degrees plus Q1 is equal to 180 degrees, right? So let's simplify this. 3x plus 2x is 5x. 40 minus 5 is 35 degrees. But we don't know what Q1 is, right? 180 degrees. Let's try and figure out what Q1 is. Oh, the reason here is because of angles of triangle, right? Q1. How can we find Q1? Well, let's use what they gave us. They gave us MN is parallel to QP, right? So that is FUN. By the way, I would recommend writing this down each time you guys get something with a parallel line. So this, and this, right? Let's see if we can make a U. We could make a U with this and this. We would say 180 minus 55, and then we say we use straight line to get that, but that seems like a lot of work. Let's try and find something else if we can find something else. Let's try N. There's no way we can make a Z, right? No. Let's try F. F, we can make a F. We can make a F if we put it like this, and this, right? Which is this here. So Q1 is equal to 55 degrees. Why? Because of corresponding angles are equal, where we are using MN is parallel to QP, right? So let's substitute it back into this equation, right? So 5x minus 5 degrees plus 55 equals to 180 degrees. Let's simplify this. So this will be 5x is equal to 180 minus 55 plus 35. Remember, because when you bring it to the other side, the sign changes. So let's see. 5x will be equal to, what is 180 minus 55 plus 35? That will be 160. divide both sides by 5. So it'll be 5x divided by 5 equals to 160 divided by 5. So this is 1x alone, right? So what's 160 divided by 5? 32. So x will be equal to 32 degrees, right? So I'm sure they'll give you a mark for your statement and your reason. Your statement and your reason, or I think just for your reason over here, and then your answer. Okay. There's a mistake that I made over here. This here should be, so 40 minus 5 is 35, not minus 35. These should be pluses. This should be a minus then. This should be 90. And then this should be, so here should be 90 divided by 5, which is equal to 18 degrees. So then 5.2.2 is give the actual size of MON, right? And angle MON is 2x minus 5, which is 2 times 18, minus 5, which is 36, minus 5, which is 31 degrees. All right, let's do question 5.3. So the diagram below is a rhombus ABCD. ABCD with diagonal BD. AB is extended to E and A is 70 degrees. Okay, let's calm down. ABCD is a rhombus, which means all sides are equal, right? And are parallel, but they don't really tell us that, so let's wait. Okay, AB is extended to E, interesting. And then angle A is 70 degrees. They didn't put it here, so let's just put it here. Okay. Calculate with reasons the size of angle ADB. ADB. All right. So let's just take this triangle out of here. We have there and over there, 70 degrees. What does this triangle look like? This triangle looks like a isosceles triangle, right? And the properties of an isosceles triangle is that this angle and this angle are equal, right? So if we have 70 there, we know that 70 plus, let's go, yeah, okay, 70 plus angle ADB plus angle ADB equals to 180. Why? Because angles of a triangle, right? So let's go 70, let's simplify this. 2 angle ADB, right? So go to 180 degrees. Put everything on the correct sides. So this will be 2 angle ADB, which is equal to 180 minus 70, which is equal to 110, right? So then let's divide by 2 on both sides. So angle ABD is equal to 110 divided by 2, which is equal to 55 degrees, right? Oh yeah, okay. So then angle ABD is equal to 55 degrees. We know that we are using both angle ADB, right, twice. But in order for the marker to know, right, you can just do this angle is this one here, right? But we also work with this angle, which is ABD. ABD, right? And then the angles of a triangle. With that reason, yeah. Right? But then, in order to get to this step, right, you would say that angle ADB BD is equal to angle ADB. Why? Because angles of an isosceles triangle. So then you can go into this step. All right. All right. So just fill in the values over here and over here. So now they want us to do angle ADC. So there's two ways to do this. The easiest way is to remember what a rhombus does, right? The diagonals of a rhombus split an angle into two halves, right? So if we have a rhombus of here, right, and we have an angle of say 140, right? When the diagonal comes, it splits that angle into 70 degrees and 70 degrees, right? So if we have 55 on the one side, right, you can say that angle ADC is equal to 2 times 55, right? Or you can say it's equal to 55 degrees plus 55 degrees. The reason in why is because diagonal of rhombus bisects the angle. So to reason this, we can say that angle CDB, right, will be equal to 55 degrees. Why? Because it's the reason in this reasoning here. The diagonal of a rhombus bisects, right? So if CDB is equal to 55, then angle ADC will be equal to 55 degrees plus 55 degrees, which is equal to, which is equal to 110 degrees. Alternatively, you could go the method of, since these are parallel, right? This here and this angle would be equal to, will be supplementary. So it would be then 70 degrees plus angle ADC, which is equal to 180 degrees, right? Rule of coint angles, right? Which ones did we use? We used AB parallel to DC. So then angle ADC is equal to 180 minus 70 degrees, which is equal to 110 degrees, which is the same. So you could use either method there. Right, so this question, calculate with reasons the size of BDE. There's B, there's D, there's E, which is this angle, right? We used this one, we used this. Now let's use this one, right? So thankfully they put it right here. So this would be DBE, right? Which doesn't this look like this? Right? Where the interior angle is equal to the interior opposite angles, right? So angle DBE is equal to interior angles, the interior opposite angles, right? Which is equal to 70 plus 55 degrees, Why? Because of exterior angle of triangle DAB, which is equal to 125 degrees. All right? Then give a reason why triangle ABD is equal to triangle BDC. To do this one, the opposite sides of a rhombus are parallel. Therefore, those ones are equal. The opposite. Yeah. Sides of a rhombus are parallel. Or rather, just parallel. Okay.